Salam sejahtera Dr. B. Today, we will present about our poster which titled Absorption of Heavy Metal Wastewater by using Agricultural Industrial Waste as Bioabsorbent. And for objective for this study is to determine the absorption isotope of lead-2 and nickel-2 and determine the absorption capacities of 3 different bioabsorbents.
3.
Okay, so as we know nowadays, the environment is polluted by heavy metals. So because of this property of heavy metal is non-biodegradable, so it accumulates in our environment, causing our food and water contamination. Causing of this food and water contamination, the examples of heavy metal is mercury. We accumulated in our food, which is fish, and we will eat this fish, causing we that as a human be contaminated by these heavy metals. So example of bioabsorbents that are naturally made is eggshell, bone, peat, fungi, seaweed, yeast, and carrot peels. And this is called bioabsorption. And the most famous bioabsorption is chitosan. That can remove heavy metals without leaving any negative impact on environment.
3.
For materials and methods, the methodology were divided into 3 parts, which is preparation of test solution of heavy metal cations. This is the first part. Firstly, we need to prepare the stock solution of lead-2 and nickel-2, and then a single test metal ions were carried out to prevent any competitive adsorption. This solution will be stored in room temperature. The second part is the preparation and characterization of adsorbents. The adsorbents we use were the bioabsorbent. The raw materials are sugarcane bagasse, rice husk, and castor leaf. These raw materials will be washed and dried. After drying process, the raw material will be grounded into smaller particles and treated with organic solvent. After treating process, it will be characterized by using FDR and SEM instruments. The last part is the equilibrium experiments. In these experiments, there were 3 25 ml of Teflon centrifuge tube were prepared, and the dried bioabsorbents were added in it with different concentration of metal ions. The pH of this solution will be set at 5 and checked in incubator shaker, and then it will be centrifuge again. The concentration of heavy metal that absorbed in the bioabsorbent will be calculated by using this equation, the Frulich equation.
Okay, for result and discussion part, for the first figure, the first figure shows about the morphology and the dimension of bioabsorbent particles, which were examined by SEM, or known as scanning electron microscopic. For the figure 1, A is the morphology for castor leaf surface, B morphology for rice husk, and C the morphology for sugarcane bagasse. So as can be seen from the figure 1, A to C, castor leaf surface is very rough and some pores are visible, while the bioabsorbent RH and SE lack the pores and their surface are smooth. The fewer number of exchangeable cation sites are present at the non-porous bioabsorbent RH and SB, which limit the adsorption of metal cations. The bioabsorbent surface might generate the exchangeable cation by the dissociation of a proton H plus or other cations from the functional groups present on the biosolvents under the specific pH conditions. The presence of coordination sites or functional groups such as carboxyl, amino, and hydroxyl groups on the surface of the biosolvents acts as a dominant factor in determining the absorption capacities of these materials. So for the figures 2, shows the result of FTIR spectrometer for analyzation of biosolvent. So the use of FTIR spectrometer to confirm the possible interactions of heavy metals ions onto biosolvents, which are Cl, RH, and Sb, and its effect on the biosolvent behavior. So from the figure 2, we can conclude that biosolvents may possess COOH groups, OH groups, or NH2 groups on their surface due to the presence of the spectral bands, as we can see from the figure 2.
Right. So next is for the figure 3. As we can see here, this figure indicates that the bioabsorption isotherms of heavy metals, which is the nickel and lead, on the selected biosolvents in measured at pH 5. So as we can see here, the isotherms in figure 3, which is figure A, for A and B and C, indicates that the order of absorption capacity for the tested heavy metals, as Cl is the most, followed by RH, and then Sb, which is sugar cane. And in all of these biosolvents, the absorption of nickel was lower than the absorption of Pb. The complexation abilities for the heavy metals are a function of the properties of heavy metals, functional groups, and of the pH of the solution. So the comparatively higher absorption of Pb suggests that the ion exchange is the primary mechanism of metal ion absorption in these biosolvents. 3.
In the conclusion, based on this study, we have selected 3 non-living biomass to develop as biosolvent. And based on the study, we have examined that lead have the highest maximum absorption capacity compared to nickel. And based on the result, Castelliff have the highest bioabsorbent properties. So highest absorption capacity.
Yeah.
Okay, that's all from us. Thank you.